showed you absolute legends. Well, this is an advanced problem in stoichiometry in calculating the quantities of products and reactants with a balanced chemical reaction. Let's look at our balanced chemical reaction here. We have Fe2O3 iron oxide reacting with carbon to produce 4 iron atoms and 3 CO2 gas molecules. So imagine like a reaction chamber, a box. It's got some iron oxide and carbon in there, just like gray granules dust. How much iron and CO2 will be produced, could be produced? Here's a cartoon image of how to envision that right there. Here's our reaction chamber. Now for this particular problem, we're going to start with 6 Fe2O3 iron oxide molecules. And we're going to start with 6 carbons. So not from the balanced chemical reaction. They react in a 2-to-3 ratio. We're going to just start with 6-to-6, like that's what we have in our storerooms today. Question here we're going to answer is what is going to be in the reaction chamber after this is all said and done? Well, there's definitely going to be some iron atoms in there, but we don't know how many. There's definitely going to be some CO2 molecules in there, but we don't know how many. And there's probably going to be some starting materials still in there. I mean, that's usually the case with Mother Nature. Like, few reactions go 100% to completion. So we're going to answer these 4 questions today using the scaffold method. Let's get started by answering by how much iron could be present right there. Okay? We have 2 starting materials. We have 6 molecules of Fe2O3 and we also, for this question, hypothetically, we start with 6 molecules of carbon, or 6 atoms of carbon right there. Right now, we have, this is very, very similar to making sandwiches. We have bread and we have peanut butter. How many sandwiches can you make? You have to evaluate both ingredients before you can finally say, I can make 5 sandwiches. Like, you need to evaluate both ingredients. And you're going to evaluate both ingredients, the bread and the peanut butter, and whichever one makes the lowest number is the best answer. We're going to do the exact same thing here using the balanced chemical reaction. For the bread, now when you make a sandwich, bread is always a 2-to-1 ratio, but for this particular problem, to find out how much iron is present, it is a 2-to-4 ratio. So we start with 2. In our scaffold here, a word cancels out, which is always a good sign. Now, starting with just our bread, we can predict 12 irons could be produced, or just 12 sandwiches. But that's only considering our bread. Let's consider the peanut butter. So we're starting with 6 pieces of peanut butter. And in this reaction, it is 3-to-4 ratio. 3-to-4. So we're going to use these 2 from the balanced chemical reaction to put into our scaffold here. And the 3C has to go on the bottom because that is the only way something cancels in our scaffold here. Based on this math here, we get a potential of 8 quote-unquote sandwiches being produced here. Now, the lowest answer is the best answer, because the lowest answer tells us we have a limiting reactant, tells us right here. So this is our best answer here, the lowest answer. So we will make 8 iron atoms in our reaction at the end. So going back to our cartoon here, there will be 8 iron atoms. So like 8 little, so in your imagination, like 8 little spheres of Fe bouncing around. Well, we started with 8 Fe. Fe2O3. So conservation of matter. Let's logic and talk about this a little bit. We started with 6 molecules of Fe2O3. That means that we had 12 atoms total of iron. 12 total atoms is what we started with. 12 total atoms is what we end with. So if we have 8 of them accounted for here, that means that there are 4 iron atoms that are not accounted for. That accounts for 2. So there must be only 2 of these Fe2s remaining in the reaction. There we got 8 here, and then 1, 2, 3, 4 irons come out of here. We're making the number 4, double check that. Let's do the same thing for, so we have 2 right there. Let's continue with this problem and calculate for the other product, carbon dioxide. We're still using sandwiches because it's still evaluating both of our ingredients to find out how much could be produced here. So starting with this much Fe2O3 and now solving for how much carbon dioxide could be produced. We use these ratios from the balanced chemical reaction. Note that this 3 and 2 come from the balanced chemical reaction. Something cancels out. This comes out to 9 CO2s could be produced. Okay. Now it's real tempting to pause right there because you have an answer, but in this advanced problem, we are going to compare both reactants and pick the lowest of the answers. One ingredient and another ingredient. So for evaluating for the 6 carbons, we go to the balanced chemical reaction. And we use those. Oh, well, look at that. This math is easy to do in the head. So this is 3 divided by 3. That's kind of cancels out nice right there. Here we have 2 answers. And we always pick the lowest answer. So 6 CO2s could be produced. So going to our picture here, 6 CO2 molecules could be produced. So if we're calculating how much iron and how much CO2 could be produced, we used a method of comparing 2 scaffolds and finding the lowest answer. In determining how much Fe2O3 and carbon is left over, we kind of logic and talk that out, just using conservation of matter. We started with 6 carbon atoms, and we produced 6 CO2 molecules. That accounts for all of our carbon. So conservation of matter, there must be 0 carbon molecules or atoms remaining in the solution, in the reaction. I hope this helps. Thank you very much.